Hello everyone, good afternoon. Good afternoon to all of you. Students, can you able to hear my voice? Just let me know in the chat box if I'm visible and audible. Yes. Thank you so much, JNV, the fourth students. Yeah. What about others? JNV Kodagu, JNV Bargal. What about you guys? Can you all able to hear my voice? Am I audible? Yes?
Yes, audible.
Okay, okay. Thank you so much, students. Thank you so much for your response. Okay. Now let's start with the today's session. Okay. So today we are going to discuss about the previous year's questions of the lesson periodic table. Okay. Yeah. Okay. Good afternoon. Very good afternoon to all of you. Now let's go into the session. Okay. So let's do some questions based on the previous years. Okay. From the periodic classification of elements or the periodic table lesson. Okay. So the topics that we are going to cover in this lesson are the introduction to the modern periodic table and the blocks in the periodic table. It includes periods, groups, everything. Okay. And the trends in physical properties and the trends in chemical properties. Okay. So in physical properties, we have four trends, right? So one is atomic radius. The second one is ionization enthalpy. The third is electron affinity or electron gain enthalpy. And the fourth property is called as electronegativity. Okay, so these are the four physical properties which we will cover here in this lesson. And there are some exceptions to the periodic trends in all these four physical properties. So that I will discuss when I am discussing the question from this particular four topic. Okay. And at last we have chemical properties like chemical reactivity and the anomalous behavior of the second period elements. So we'll study some questions from that. Okay. So this is what we are going to do today. So I think we can move on to the first question of today's session. Are you all ready? So keep your notebook and pen or pencil with you. So once I show you the question, all of you try to do that in your notebook and try to give me the correct answer in the chat box. Then later on we will discuss. Okay. Is that okay for all of you? Are you all ready? Shall we start? So just give me a thumbs up or type yes in the chat box so that we can proceed further. Yes. Okay. So the first question for today's session is you have to match list 1 with list 2. So this is a question from JEE Mains 2024. Okay. And in the list 1, we have the elements. And in list 2, we have the electronic configuration of the element. Okay. Such an easy question, right? So you just need to know the atomic number and the outer electronic configuration of each group. So if you know these two things, you can able to find out the answer quickly. Has anyone got the answer right now? If anyone has got the answer, you can put that answer in the chat box. It's very easy, no? Very, very easy question it is. You can take 15 to 30 seconds to solve this question. Somebody is feeling very difficult to solve, you can take 30 seconds or 45 seconds to solve this question. I am waiting for you. So if you have got the answer, just type the option in the chat box. Nobody has got the answer till now. Can anyone tell me the atomic number of nitrogen? Yeah, I have got one response. So yeah, from JNB Vargal. JNB Vargal students are saying option C as the correct answer. Hi JNB Chittoor students, good afternoon. So right now we are in the first question of today's session. So try to follow the class, try to join as soon as possible. Keep your notebook with you and try to solve the questions and give me the answer. So JNB Bargal has given option C as the correct answer. What about others? What about others? Is option C right or wrong? What do others think of it? Okay, let's check. So let me go from the nitrogen. Okay. So nitrogen atomic number is 7, right? So what is the electronic configuration? So it is 1s2, 2s2 and 2p3. Okay, so this is the complete electronic configuration of nitrogen. Okay, JNB Varangal is also saying option C as the correct answer. Yeah, option C is the correct answer. Very good to both of you. So now let's discuss that so that others also can understand. Okay, so here 1s2, 2s2, 2p3 is the electronic configuration of nitrogen. So where 1s2 is the electronic configuration of helium. So what we can do, instead of writing 1s2, we can write helium with the outer electronic configuration of nitrogen as 2s2 and 2p3. So that's why A is going to 3. Okay. Next coming to B. Sulfur. Sulfur belongs to which group? Can anyone tell me the group number of sulfur? It belongs to 16th group. Okay, it belongs to 16th group. Oxygen group member is sulfur. And also the atomic number of sulfur is 16. Atomic number of sulfur is 16. So atomic number is also 16 and the group number is also 16. So for all the members who are presented there in the group 16, they have the outer electronic configuration as NS2 NP4. NS2 NP4. Okay. So here in the given four options of list 2 in the electronic configuration of list 2, we have 3s2 3p4, which is NS2 NP4 configuration only in 2. Okay, and also you can check with the atomic number also. If you write 1s2 2s2 2p6 3s2 3p4, you will get that. Okay, so B goes to 2. And coming to C, bromine. So bromine belongs to 17th group. Okay, bromine belongs to 17th group. For all the 17th group elements, the outer electronic configuration will be NS2 NP5. Okay, so we have only one option, right? With NS2 NP5, which is 4s2 4p5. Bromine belongs to the fourth period, and that's why the outer electronic configuration is 4s2 4p5. Okay, so C goes to 1. And at last D, krypton. Krypton is a noble gas. So it belongs to group number 18. Okay, so for 18th group elements, the configuration is NS2, NP6. So that's why D is going to 4. Is that all right for all of you? So what you need to do, you need to know the group number of at least first 30 elements in the periodic table. Okay, so try to memorize the first 30 elements in a group wise manner also. Okay, and for some elements like bromine, krypton, so for these elements you have to learn all the elements in a group wise manner. Like if I go for group 17, so in group 17 I will have fluorine, chlorine, bromine and iodine. If I go for group 18, then it starts from helium, neon, argon, krypton, xenon, radon. So like this, some groups are there which are very important. So you need to memorize the elements present in those groups. Okay, so those very important groups are group 17, group 18, group number 1 and group number 2. Okay, so try to memorize the elements in a group wise manner. Group wise means from top to bottom for these particular groups, these 4 groups, and for the remaining you have to study from atomic number 1 to 30. Is that all right for all of you? So any doubt from this question? Shall we move on to the next? Do you want to ask anything from this? Shall we proceed with the next question, students? I'm waiting for your response. Yes or no? Fine. The second question is, arrange the following elements in increasing order of electronegativity. So we have nitrogen, oxygen, fluorine, carbon and silicon. Okay. And electronegativity is one of the physical property, the fourth physical property. We have to choose the correct answer from the options given. Okay. So how to find out the correct answer? Before moving on to the discussion or the explanation for this question, I would like to ask you one question from this particular topic. The question is, which is the most electronegative element in the periodic table? Do any of you know the answer for this question? Which is the most electronegative element in the periodic table? We have 118 elements in the periodic table, right? So among those 118 elements, which is the most electronegative element? The first most electronegative element. Very good, Amal. It is fluorine. Okay. So obviously, the fluorine option, the highest electronegativity with fluorine is going to be the correct answer. Yes. Jane B. Bhavnagar students. Yeah. So either option A or B. So that is going to be the correct answer. We have the right option either in A or B. Now, Jane Vivargal is going for option A. Very good. Option A is the correct answer. Option A is actually the correct answer. Let's discuss. So the first most electronegative element is fluorine. Okay. So if you do not know this, just write this and keep this in your notebook. Okay. So at least try to get few points, few things from each class. Okay, so we have the question solving session only once in a week. Okay, so once you go with this, once you complete this session, you should have the confidence. Okay, I have learned at least these many points from this session, kind of thing. Okay, so for that you need to keep your notebook with you and try to write the hints or the tricks or the statements, very easy statements which I am telling you. Okay, so that it will be very helpful for you during your examination time. And for your revision purpose also, it will be very helpful. Got it? Now, what I told you, the first most electronegative element in the periodic table is fluorine. Now, who is the second most electronegative element? First most is fluorine. Second most is oxygen. Second most is oxygen. So, who is the third most electronegative element in the periodic table? Nitrogen and chlorine. Nitrogen and chlorine. Okay. First most is fluorine, second most is oxygen, third most is nitrogen and chlorine. So nitrogen, chlorine both have the same values of electronegativity. So both will fall in the third line. Got it? Yeah. So from this data itself, we can able to get the correct answer. So first is fluorine, second is oxygen, then the third is nitrogen. Okay, electronegativity is very high, and then comes carbon, then silicon. Okay, so why carbon is having very high electronegativity compared to silicon. So here you can see from the symbol, right? Carbon is having the highest electronegativity value compared to silicon. It is because across the period, electronegativity increases. Okay. So we have fluorine here, oxygen, nitrogen, chlorine, etc. Nitrogen, carbon, silicon, phosphorus, sulfur, etc. It goes on. Okay. On moving down the group, electronegativity decreases. Electronegativity decreases. So if I compare carbon and silicon, so carbon will obviously have the highest electronegativity value, right? Because it decreases. Silicon will have the least value. So that's why the electronegativity of silicon is very less compared to carbon. All right for all of you. So option A is coming out to be the correct answer for this question. Is it clear? Shall we go for the next? Any doubt from this question for anyone? Can you all able to understand? Let me move on to the next question, students. Okay. So the next question is from JEE Mains. So the question is, anomalous behavior of oxygen is due to its. So what is meant by anomalous? Anomalous means unique or different, I can say. Okay, the different behavior or the unique behavior of oxygen is due to. So who is this oxygen? Oxygen is the first member of its group. So oxygen group number is 16. Oxygen belongs to 16th group and it is the first member of this 16th group. Okay. So the first member of each group, okay, they behave differently. They all have some unique behavior due to three reasons. Due to three reasons. Can anyone give me those three reasons in the chat box? Those first member of each group behave differently. Can anyone tell me why they behave differently? I told you it is due to three reasons. Can anyone give me those three reasons in the chat box? I'll give you 15 to 30 seconds. So what are the reasons for the unique or anomalous behavior of oxygen or the first member of each group? It is not only for oxygen, it is for fluorine. Fluorine is the first member of 17th group. And it is also for nitrogen. Nitrogen is the first member of 15th group. So all these first member has the unique property. So Amal is going for option B. I was asking, no, the reason, the three reasons for the anomalous behavior of the first member. Okay, I'll tell you. The three reasons are, one is small size, one is due to the small size. Okay, so this is the first reason. The second reason is due to high electronegativity. It is due to high electronegativity. The third reason is the absence of d orbital. Absence of d orbital. So if you look into the first member of each element, they won't have d orbitals and their electronegativity value will be very, very high because on moving down the group, the electronegativity decreases, I told you in the previous question. So means the first member will have the highest electronegativity value. So all of them will have high electronegativity and the size of those elements will be small. On moving down the group, size increases, right? So the first member will have the least size value. Got it? So because of small size, high electronegativity and the absence of d orbital, those elements behave in a different manner. Okay. So the reason 1 and 2 is given in option B, right? So most of you have given option B as the correct answer. That is right. Okay. JNV Varangal students, they have given C first and then B. Yes, B is the right answer. Very good. So if you do not know this, please write the reasons for this anomalous behavior of the first member of each group. Okay. Shall we go for the next? Shall we go for the next, my dear students? The next question is the correct decreasing order of atomic radii of lithium, beryllium, boron, and carbon is. The correct decreasing order of atomic radius. Atomic radius is again the physical property, the first physical property, right? So here they are asking the trend, the correct decreasing order of these four elements. So who are these four elements? They belong to which period? Can anyone tell me the period number of these four elements? The period number of these four elements: lithium, beryllium, boron, and carbon. Can anyone give me the period number? Period means the horizontal row. Okay, the horizontal row from left to right. From left to right. Yeah, it belongs to the second period. It belongs to the second period. So these are the base, all the four elements belong to the second period. Okay. So for second period elements, these four are not only the second period elements, we do have some other elements also. We have nitrogen, we have oxygen, we have fluorine, etc. But if you look into the atomic radius across the period, the atomic radius decreases. So this is the trend for atomic radius across the period. Okay, yeah. Yeah, option B is the correct answer. I will come to that. So across the period, atomic radius decreases. So who will have the highest radius value? Lithium, then beryllium, then boron, carbon, etc. Okay. So these four are given in option B. So that is the correct answer. Very good. So atomic radius of lithium will be more than beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So if you go from left to right in the periodic table, the general trend is the size decreases across the period. Okay. Shall I go for the next? I hope this question is clear to all of you. So for all the periods, not only for second period, for all the periods, the atomic radius decreases generally across the period and it increases on moving down the group. Okay. Atomic radius and ionization energy we have, those are inversely proportional to each other. So let me talk about the ionization energy in the upcoming questions. So now you write the trend for atomic radius. Across the period decreases, on moving down the group atomic radius increases. Okay, so this is the trend. Now we'll go for the next question. Yeah, the correct order of first ionization enthalpy for the given four elements is. So again, we have four elements. One is carbon, nitrogen, oxygen, and fluorine. Okay. So again, these four elements belongs to which period? Second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Right? So in all the four options, we have the jumbled order for these four elements. So we have to find out the correct answer. So can anyone tell me which is the correct answer? Option D. Four, yeah, option D. So JNV Bhavnagar is going for option B, D. Everybody is going for option D. So most of you. So Azer one is going for option C. Abhishek is going for B. Okay, let's discuss. Let's discuss. So what is ionization enthalpy first of all? So I have an atom and I have the nucleus I have shells. So this is shell number 1, this is shell number 2, this is shell number 3, etc. Right? So I do have electrons in each shell, right? I do have electrons in each shell. So these are the 2 electrons in shell 1, and I have electrons in shell 2, and I have electron in shell 3 also. Now what I want to do, I want to remove the outermost electron. Okay, I want to remove the valence shell electron. So to remove that electron, what I have to do, I have to give some energy, then only that electron will come out from this atom. This is an atom. Okay. So the energy required to remove this electron, the energy required to remove this electron is called as ionization enthalpy. Okay. Suppose if this atom is sodium. Okay. After the removal of one electron from this sodium, it will be converted to sodium cation. Okay. So to remove this electron from the sodium, from this isolated gaseous atom, some amount of energy is needed for that atom. So that energy is called as ionization energy or ionization enthalpy. Okay. So if I am removing the first electron of the sodium, then it is called as first ionization enthalpy. Then if I am going to remove the second electron of sodium, it is second ionization enthalpy. Okay. So this is the definition for ionization enthalpy. Now we do have some exceptions for second period elements. So who are the second period elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, right? So these are the elements. Actually, if you ask me the trend across the period for ionization energy, it increases. Okay? It increases across the period. Ionization energy increases. Okay. So I have given you 3 physical properties trend, right? One I have given for atomic size and I have given for electronegativity. This is the third physical property and its trend. So across the period, ionization energy increases. Okay, means neon should have the highest value, then fluorine, oxygen, nitrogen, carbon, boron, beryllium, then lithium. So this is the expected order, I can say. This is the expected order of ionization enthalpy. Okay, but this was not the observed order. But what is the observed order? So this beryllium and boron have interchanged with each other, and nitrogen, oxygen have interchanged with each other due to the fully filled shell. And here the half filled configuration. Okay, that you would be knowing. So because of the completely filled shell of this beryllium, which has 2s2 configuration, which is more stable, more amount of energy is required to remove the electron from beryllium compared to boron. So because of that, boron will have the least value, then comes beryllium, here is lithium. Okay, then carbon, and here if you go for nitrogen and oxygen, nitrogen has half filled configuration 2p3, but oxygen has partially filled configuration which is 2p4. So half filled configurations are more stable compared to partially filled configuration. So in that case, nitrogen will be more stable, so the energy required to remove the electron from nitrogen will be more, okay, than oxygen. So oxygen and nitrogen is more than oxygen, then fluorine, then neon. So this is the observed order for ionization energy of the second period elements. Okay, so we don't have all the elements of period 2 in the options. We do have only the 4 elements: carbon, nitrogen, oxygen, fluorine. So you can able to see the order, right? Carbon, oxygen, nitrogen and fluorine. So just try to find out this. It is given in option D. Okay. So option D is the correct answer. Option D is the correct answer. Most of you have given option D only. Okay. For others who could not able to get the answer or who needs the explanation for this, I hope this explanation is clear to all of you. Okay. If you're having any doubt also, you can put that in the chat box, or if you want me to explain it again, I am ready to explain it again. Got it? So ionization energy increases across the period and decreases on moving down the group. Is it clear? Shall we go for the next? Yes. Ionization energy increases across the period and decreases on moving down the group. Okay. Genuine Haveri students, I am repeating it for you. So the expected trend is this. So according to this general trend, I should get the trend like this. But for second period elements alone, we have some exceptions for beryllium boron and nitrogen oxygen. Okay. So due to some reason which I have discussed. So what I have to do, I have to interchange these two places. Okay. And I have to interchange nitrogen and oxygen place to get the observed trend. Observed means from the experiment, they have observed this only. Beryllium had the highest ionization energy compared to boron, and the same way nitrogen had the highest ionization enthalpy value compared to oxygen. Okay. Actually, oxygen should have the highest value, but due to the stability reason, nitrogen has half-filled configuration, so it is stable. So more amount of energy is required to take out the electron from a stable configuration. Okay, so it is interchanging the place. All right. Jane Haveri, is that okay? Okay. Now moving on to the next question. Question number, this is from JEE Main. The correct sequence of electron gain enthalpy of the elements listed below is. So again here, we have to find out the electron gain enthalpy. Correct sequence of electron gain enthalpy. So what is this electron gain enthalpy? So it is also one of the physical property. I told you 4 physical property, right? So this is the third physical property. So if an atom gains one electron, if an atom, so this is an atom, okay? So this is an atom. If this atom gains one electron from outside, so some amount of energy will be released from this atom. And that energy is called as electron gain enthalpy. That atom is called as, that energy is called as electron gain enthalpy. Okay. So now we have to find out the correct sequence of this. I'll tell you the trend also. Okay. Across the period, electron gain enthalpy or electron affinity increases. On moving down the group, it decreases. So using this, you can find out the answer. Also, we have some exceptions for second period and third period element. So I will come to that later. Okay, I will come to that later. So what is your answer? So one of you have given option B. Kalaburgi students are saying option B. Babnagar is going for option D. Which one is correct? What about others? What about others? Give your opinions. Okay. Before moving on to the correct answer, I will give you the electron gain enthalpy values of all these 4 elements. Okay. So Manik is going for D. Abhishek is going for B. Okay, let's check. So here I have given you the electron gain enthalpy values for the 4 elements. So can you able to guess the correct answer now? Is it option B or D? Is it option B or D? Which is having the positive value, argon, right? So A, then the least negative is sulfur. So D, next is bromine, B, and the last is fluorine. The more negative is fluorine, which is C. So option B is the correct answer for this question. Okay, option B is the correct answer for this question. Clear for all of you? So what are the four physical properties which we have discussed in the last four questions? One is the physical properties and its trend. Okay, trend across the period and on moving down the group. So I'll write across the period and on moving down the group. Okay, physical property across the period and on moving down the group. Okay, so the first physical property is atomic size or atomic radius. So across the period, it decreases and on moving down the group, it increases. The second is ionization enthalpy. The third is electron affinity. The fourth one is electronegativity. Electron affinity or electron gain enthalpy. Okay, which we have discussed in this question. So for all these three, it is the opposite of atomic size. If atomic size decreases across the period, it increases across the period for other three. If it increases on moving down the group, then it decrease. The other three will decrease on moving down the group. That's all. Okay. Atomic size is inversely proportional to the other three. All right. Is it clear? You can write this general trend. This is the general trend. Okay. This is the general trend in the periodic table. We do have some exceptional cases in each period. Like in the last second period, in the last question when I was discussing about the second period, I told you, right? So we do have some exceptions between beryllium and boron and nitrogen and oxygen. So those will fall under exceptions. But this is the general trend. This will be very useful for you for solving some questions. Okay, just apart from using the exceptions. All right. So are you all done with this? Shall we go for the next? Okay. So let me move on to the next question from JEE Mains again. The statement that are correct about the species O2 minus, F minus, sodium plus and Mg2 plus. So four statements are given. In the statement A, it is said that all are isoelectronic. What is meant by isoelectronic? Iso means same. Okay, electronic means electrons. Isoelectronic means same number of electrons containing species. Okay, so we have to check whether it is correct or not. Then JNV Babnagar, you got the answer? Okay, so just tell me whether statement A is correct or not. All are isoelectronic. What do you guys think? Are they isoelectronic with each other? Yes, because if I go for O2 minus, so the atomic number of oxygen is 8. Okay, atomic number of oxygen is 8. Means they have 8 protons. They have 8 protons inside it. So what about the number of electrons? So oxygen has gained 2 electrons. So what I have to do, I have to add this 2 to the atomic number. Okay, so many of you are going for option A also as the correct answer. And many more are going for option B as the correct answer. Now we'll discuss. And we'll see at the end which is the correct answer. Okay. Okay. So coming to this 8. So atomic number of oxygen is 8. So already there are 8 electrons in oxygen. And also it has gained 2 electrons. So 8 plus 2 is 10. Then coming to F minus. The atomic number of fluorine is 9. And it has gained 1 electron, F minus, right? So 9 plus 1 is 10. Then if I go for sodium plus, the atomic number of sodium is 11, but it has lost one of its electron. Plus means it has lost. Okay. So 11 minus 1 is 10. And coming to Mg2 plus, the atomic number of magnesium is 12. So 12 has lost 2 electrons. So 12 minus 2 is 10. All of them have 10 electrons. So they are all isoelectronic with each other. Okay, so this statement A is correct. Coming to statement B. All have the same nuclear charge. What do you think about this? All have the same nuclear charge. What is meant by nuclear charge? It is the number of protons, which is nothing but the atomic number. Just nothing but the atomic number I can say. The atomic number of oxygen is 8, the atomic number of fluorine is 9, for sodium it is 11, and for magnesium it is 12. The number of proton, which is actually the atomic number or the nuclear charge, they are different for each species. But in statement B, it is given that all have the same nuclear charge. Do they have the same nuclear charge? Obviously no, right? So statement B is incorrect. Statement B is incorrect. Then coming to statement C, O2 minus has the largest ionic radii. So how to find out the ionic radii for isoelectronic species? So for that, I will give you one relation. Use that relation to find out. Okay. The relation is for isoelectronic species, ionic radii is inversely proportional to the atomic number. Ionic radii is inversely proportional to atomic number. Okay. So all of you write this relation and keep this in your notebook. Okay. So the one which is having the highest atomic number will have the least ionic radii. So who is having the highest atomic number here? Magnesium. Its atomic number is 12. So it will have the least radius value. Okay. Then who is next? Sodium. Next one is fluorine, F minus, and the one which is having the highest ionic radii is O2 minus. So in statement C, it is said that O2 minus has the largest ionic radii, and that statement is also correct. Okay. Then coming to statement D. Mg2 plus has the smallest ionic radii. So from this order itself, we can say no. So O2 minus is having the highest ionic radii and Mg2 plus is having the smallest ionic radii. Got it? So statement D is also correct. So A, C, D. So these three are the correct statements in which option B is the correct answer for this question. Is it clear for all of you? Students, those who have gone for option A as the correct answer, is it clear now? Statement A is also correct because they are all isoelectronic species. Okay. Abhishek and Manik, is it clear? Any doubt? Okay. So now we'll go for the next question. Very easy question from NEET 2022. The IUPAC name of the element with atomic number 119 is. So what is the answer? You can tell me that, ma'am, we have only 118 elements in the periodic table. Then how come this 119 and how this is out of syllabus kind of thing and all, no? You may think like that. But if you discover the element with atomic number 119, how will you name it? We have a set of rules given by IUPAC, right? To name the compounds with atomic number greater than 100. So using that rule, we have to find out the answer. So here for this question, many of you are going for option B. Option B, option A, and many are going for C. A, B. So I am getting all the options in the chat box. Okay. Let me give you the correct answer first. Then I will discuss. Okay. Option A is the correct answer. Which is the correct answer? Option A. Why? So what is that rule? Which rule has to be applied for finding out the nomenclature of elements with atomic number greater than 100? So here is the list. Okay. So in the first column, I have the digits. In the second column, I have the names of those digits which has to be used. And in the third column, I have the abbreviation. Okay. So abbreviation is nothing but the first letter of this name. For nil, it is N. For un, it is U. For by, it is B. So like that. Clear? So now what was the element? It was 1, 1, 9. Now start from 1. So for 1, what we have to use? UN. Yes, UN plus. And the next digit also 1 only. So again I have to use UN. And the third digit is 9. So for 9, what I have to use? N. E, N, N. So these are the root words. And we have to use a suffix also. The suffix is I, U, M. So what is the name? Un, N, em is the name of the element. This is clear? So basically what you need to do, you have to memorize the root word or the name for all the 10 digits. That's all. Nil, un, bi, tri, quad, pent, hex, sept, oct and n. So these are the names of all the 10 digits. So just try to memorize all these 10 digits, name or the root word, so that it will be very easy for you to answer this type of question. Okay, so let me go to the question first. Again, now you can able to understand why option A is the correct answer, right? And NEM. Is it all right? Only one letter is changing here, no? Between option C and A. Will be very, very careful in selecting the correct answers. Okay. Oct will come only for 8. And here we have N, but here in option B we have nil. Nil means 0. 109. But we are asked to find out for 119. So it is NEM. Students, can you all able to understand? Please try to memorize this list, which it will be helpful for you to get the correct answer. You don't have to spend much of your time in this type of questions, right? If you know the root words properly, okay, then you can get the answer within a fraction of a second. Okay, and you can go for the next question in the exam. Such kind of easy questions they are. Now I have taken a similar type of question from the same concept. Okay, from the same concept, but there we will discuss in a little bit different way. So I'll go for that question. Identify the incorrect match. So I have 4 names and I have the IUPAC official name of those 4 elements. Okay. So using this name, you can find out the atomic number. Annil, annium means it is 101. Annil trium means it is 10. Tri means 3. Annil hexium means it is 106. And annium. Annium means 111. Okay. So these are the atomic numbers. But what is the IUPAC official name? What I need to do? Here you don't have to apply any concept. You don't have to apply any concept. You just need to memorize the list which is given in your book. Okay. So let me give you the correct option. Then I will give you the list here also. You can take the screenshot or you can note it down or you can take it down from the book also. Okay. So which is the correct answer? Option D. Option D is the correct answer. Here we are asked to find out the incorrect match, no? We are asked to find out the incorrect match, right? We have to find out the incorrect match. Option C is the correct answer. The incorrect match is option C. Yeah, yeah. So very few schools have given option C as the correct answer. So annium which is going to Dam Stadium, is the incorrect IUPAC official name. Now I'll give you the reason that why it is an incorrect match. Okay. So keep all these elements in your mind. Okay. 101, 103, 106 and 111. So now you see the list. This is the list. So 101 we had no 101. Nil and EM. So it is medellivium. And 103 it is Laurentium. And what else we had? We had 106, which is Seaborgium. And we had 111, which is actually Rongenium, and it is not Darmstadtium. Okay. So 111 in the 111 column, in the row, we had Darmstadtium given in the question, which is actually incorrect. It is not Darmstadtium, it is Rongenium. So that's why the last option D is the incorrect. Last statement D, correct answer is option C. Correct answer is option C. Okay. Okay. Correct answer is option C. All right for all of you? Any doubt? So what you have to do? You have to memorize the IUPAC official name for each element. Okay. The symbol is very easy. If you know the IUPAC nomenclature, you can get the symbol. And the IUPAC official name, there is no other way you have to memorize. Got it? Shall we go for one more last question for today's session? Any doubt from the session for anyone? No doubt? Okay. Now let's go for the next. Yeah, this question is a statement type question. I have two statements. Statement 1 says the metallic radius of sodium is 1.86 angstrom and the ionic radius of sodium plus is lesser than 1.86 angstrom. Okay. So what does statement 2 says for this? Ions are always smaller in size than the corresponding elements. Ions are always smaller in size than the corresponding elements. So what is your answer? Which option is correct? D? Sure? Option D is the correct answer. So all of you are going for option D. Okay, most of you are going for option D, which is the correct answer for this question. Very good. Yeah, D is the right answer, students. Now let's discuss. Okay. So in statement 1, we have the metallic radius of sodium is 1.86 and ionic radius is less than this. I will give you one relation. So if the atom is same, and if I have the cation and the anion of that corresponding atom, then the radius of the cation will be small. Okay, I'll give you that relation. So I have a cation and I have the neutral atom, and I have the anion. Okay, clear? So the neutral atom is sodium. If it loses one of its electron, it will become a cation. It won't gain electron basically. Okay, if it gains, it won't gain. If it gains, it will form an anion. Okay, but this is not the case with sodium. So here we have only cation and neutral atom. Okay, so but I'll give you the general trend. So if I compare these three, cation will be lesser in size compared to neutral atom, and neutral atom will be lesser in size compared to anion. Okay. So now if I compare sodium plus and sodium plus cation is lesser in size compared to sodium atom. So statement 1 is correct. Okay. Now coming to statement 2. Ions are always smaller in size than the corresponding elements. Is that right? No. Ions means they are trying to mention both cation and anion. Ions means both cation and anion will fall under ion category, right? Only the cations are smaller in size than the corresponding element. Only the cations are smaller in size than the corresponding element, which is a neutral atom. Okay, this is the element and this is the cation. Cations are smaller in size compared to the corresponding element, not the anions. But here, ions means they are meaning both the ions. So that cannot be correct. So that's why statement 2 is false and statement 1 is correct. Clear and all right for all? Any doubt from the statement type of question? No doubt? Okay. Okay, students. I will like to wrap up the today's session as it is already 4 p.m. I hope this session is very useful for all of you and I hope at least you guys have learned at least one thing from today's session. Am I right? Am I right? I hope at least you guys have learned at least few things, at least one thing. Okay, at least one few things from today's session. So thank you all so much for attending the class. So meet you all with the next set of question in the next class. Okay. So if you have any doubt, if you want to ask anything, you can bring those doubts in the next class or you can bring those doubts in the weekdays classes also if you are attending the class. Okay. Thank you so much for attending the class and thank you so much for your patience. Till then, take care. Bye bye. Yeah. Thank you so much, students. It's very nice to have you all here. Thank you.